Hi guys, we're back with another Data Insights webinar. Today we're going to discuss an MSR set. Now I'm sure, with the moment I said MSR, it did evoke quite a few negative feelings among many of you. All right, so this is again giving me trouble today. Yeah, right. But then, when they give you sets like this, the one that we're going to discuss today, it's an official set, then I'm sure those feelings just get stronger because it does come across as a difficult question. But frankly, it's not. Yeah, there is this one basic concept that we need to understand really well. And in fact, we're going to understand the concept of percentiles today. And once we do that, then all the questions in the set do make a lot of sense. Yeah. Again, let me reiterate, I've already talked about this a few times before, that MSR usually is a little tougher. You do have 5 extra minutes in data insights. So out of those 5 extra minutes, you can allocate, let's say, 2 extra minutes to MSR. So 8 minutes is a lot of time, right? You will feel a whole lot better about spending that time, that initial few minutes, to figure out the various tabs, what is given in what, etc. Yeah, and you're not going to hate it as much then. So, right, as a strategy, ensure that you give, let's say, about 8 minutes to MSR. If you're able to do it in shorter time, good for you. If not, at least you'll not be rushed and you'll not feel worried about it. Yeah. Okay, so then I'll share this set. We will need to, so first what I'll do is I'll explain the data given to us. After that, I'll let you try out the questions. Hopefully you will find them easier once we've already discussed, the set as such. If not, anyway, we'll discuss each question. Now there are 6 questions, so we'll need to go a little faster. Maximum time we'll spend in discussing what the data is, and that core concept that I'm talking about, we'll spend maximum time on that. Yeah. All right. So let me share my screen with you. Give me a moment. All right. There you go. Let me know if you can see it. Let me know if there is any problem. Let me just pull it down a little. I hope you can see the screen properly. Yeah. All right. Fine. So then, just left it, so it started again. All right. Okay, so let's discuss the data which is given to us. Now, these are the 2 tabs. This is one tab and this is the other tab. I've put them both together on the screen, not because we need to compare them at the same time, not because it makes our question easier. No, it doesn't. It doesn't really matter. Normally, we'll be looking at one graph at a time, but only because it's easier for me to work this way and to explain things to you. Yeah. Otherwise, it'll really not make a difference. Even if they are on 2 different tabs and you're not able to see both of them at the same time, it doesn't really matter. And we'll discuss why. Yeah. Okay. So the World Health Organization has produced a comprehensive set of growth standards for children. Now, these standards are based on studies of children living in 6 nations on 5 continents under optimal conditions with respect to health and nutrition. All right. The table displays the percentile distribution. Wait just a moment. There is a Q&A. Yes, no. So if you're talking about official mock question, this question is from the OG or the review guide. It is not from GMAT Focus. If you mean official mock, then this is not from a GMAT Focus test. Yeah. Yeah. Okay. So has produced, where were we? Yes. Now the table displays the percentile distribution of height in centimeters at 3 months into 3-month intervals for boys ages 2 through 5 according to the WHO model. In a model population, okay, what are they talking about? For boys ages 2, 3 through 5. So I see age is given over here, age 2 is given, age 5 is given in 3-month intervals. So, this means that this is 2 years, 3 months, this is 2 years, 6 months, right? Based on the data, I can see what they mean in the table. All right. Now, in a model population, a large population of boys ages 2 through 5 that confirms to the WHO growth standards. What is a model population? In a model population, then they define what is a model population. It's a large population of boys ages 2 through 5 that conform to the WHO growth standards. So whatever, it's a large population of boys, essentially lying in the ages 2 through 5. Okay. So in a model population, for n is equal to 3, 15, 50, 85, and 97, Nth percentile in height for a given age is the unique height among boys of that age that is greater than or equal to n% and less than or equal to 100 minus n% of heights of boys at that age. Now, you know what, when you read it for the first time, perhaps you're very unhappy. It has a lot of things. There are a lot of numbers, this greater than that, this lower than that. What does it really mean? Look, we know what a percentile is, right? And how do we know it? Because we talk about GMAT percentile all the time, right? So take that as your anchor, take that as your base. I know what is my target? My target is to get a 99 percentile. What does that mean? It means that I want marks of 99, which are at a 99 percentile, which means that my marks are greater than 99 people out of every 100 people. Yeah. That is what we mean by 99 percentile, right? I say that I have more marks than almost everybody else, right? That is how we use percentile every day, even though it doesn't matter whether you use, you've learned statistics, whether you know percentile as a concept, it doesn't, nothing matters. What every person who is planning to take GMAT does know very well is the concept of a percentile, because we talk about 99 percentile or whatever, 50 percentile, 80 percentile, almost every day since we're preparing for GMAT, right? So just keep that thing in mind. Now, percentile means that, when I say I want a 99 percentile, it means that I want marks which are more than 99 of any 100 people. Yeah. Now look at what is given to me. I'm given n is equal to 3, 15, 50, 85, or 97. Nth percentile in height for a given age is the unique height among boys. So I'm talking about the nth percentile in height. So I'm saying, let's say 97th percentile in height. I said this boy has 97th percentile in height, which means that, coming from that same logic of our 99 percentile score, what will I say? ISO 97th percentile means he's taller than 97 people in a group of 100, right? He's a really tall guy for his age. The data we are given is for a given age. Now, for a given age, I'm given 3rd percentile, 15th percentile, 50th percentile, 3rd, 15th, 50th, 85th, and 97th percentile. Essentially, this is the height which lies at this percentile, which means that if a boy's height is 90.3 and the boy is 2 years old, it means that this 90.3 is taller than 85 boys in a group of 100. Yeah. Now they have defined it for us. Of course, they have to give us the definition of what they mean by an nth percentile. So they say that this is the unique height among boys of that age that is greater than or equal to n%. So 80, this height of 90.3 is greater than or equal to the height of 85% of the boys. That pretty much that matches up with what we think about percentile as well, right? They've just included the equal to as well over here. Great. Doesn't matter how you define it. Percentile can be defined in that way as well. Like, for example, it can be, when we say 100th percentile, got a score of 100th percentile. How are they defining percentile in that case? They're saying greater than or equal to, right? Equal to is also included in that. That only then can you get 100 percentile, right? All right, or less than or equal to 100 minus n%. You don't have to worry about it. It just makes sense, right? When I say that my score is, let's say, at a 99 percentile, I can say that it is less than 1%, right? So 100, if my n is 99, my 100 minus n is 1. So essentially, this is all that they have given us, that it is less than or equal to 100 minus n%. When I say that the height is at 97th percentile, that means it is equal to or more than 97% people and equal to or less than 3% people. Matches up, makes complete sense, right? So even though it seems like I don't know what is given over here, essentially they are just defining percentile for us. Yeah. All right. Now look at the data. Does it make sense? So let's say age 2, they are saying at age 2, the heights of our 3rd percentile is 81.4, 15th percentile is 83.9, etc., etc. Now it makes sense that the height is increasing for a 2-year-old. If the boy has 81.4 centimeter height, then the height is a little less, right? He's taller than only 3% of the boys. But if his height is 92.9, then he's taller than 97% of the boys. Yeah. All right. Now, when we look at the age of 2 years, 3 months, I'm putting together all the boys of the age 2 years, 3 months, then 83.5, a higher height is at third percentile, and that makes sense as well, right? Why? Because now, the age is increased. So of course the height increases with age. So then now the third percentile lies at 83.5. So that means that 83.5 centimeters is the height at which you'll find that this is more than 3% of the boys. And 95.7 is the height, which is at 2 years, 3 months, which is more than 97% of the boys, the height of the boys, right? So the data makes complete sense to us. Of course, as the age increases, I am seeing that the third percentile is increasing, which is obvious because as people get older, their height increases. And I'm talking about 2 to 5 year olds. So of course, the height is increasing, right, continuously in this age group. And then I see that with the percentile, of course, the height is increasing, which we said that makes complete sense. So this is the data given to us. We are given the percentile of height in centimeters by percentile relative to the age. So what did I do? To get this data, think about, first of all, what did I do? And this point is extremely important because it's going to help us solve a lot of questions later on very, very quickly. So you should understand it. How did I get this data? You know what? So I had this big group of 2 to 5 year old little boys, right? So I got all the 2-year-olds together. Now I have this one big group of 2-year-old boys. Here I have only 2-year-old boys, right? And then I check their height. Let's say I got total 100 2-year-old boys over here. I checked their height. So then there were 3 people who were perhaps 3 or 2, whatever, who were less than 81.4. Yeah, if it is greater than 3%, then of course the fourth person is going to be, since I'm talking about a large group, more likely this number is going to be 1,000 or 10,000. So it wouldn't really matter, right? That one small number will not matter. So essentially, this entire group is of 2-year-olds. Yeah. And from this group, I found this particular data. I found that the tallest among them perhaps was a 95 centimeter boy. And then the boy whose height was 92.9, he was taller than 97% of the boys, right? So this is how I obtained this data. Then I made a separate group for 2 year, 3 months old. And perhaps the ones who were in between, I put half of them there and half of them there. I rounded down and rounded up, or whatever I did, doesn't matter, right? So this is how I obtained this data. Now tell me one thing. This table, does it give me information about the percentile of age? Look, I can say over here, I can say that, this person, he's tall for his age. Think about it. Can I say that he's a 2-year-old, but his height is 92.9. So I can say that, he's tall for his age, right? But then does it mean that can I find the percentile of age based on height? Here, what am I given over here? This says nth percentile in height for a given age. Now, can I flip it? Can I say the nth percentile of age given height? Can I say that what is for example, if I pick up this height, let me pick up, say, 90.3 as the height. Can I ask you, can you tell me what is the nth percentile of age given this particular height, 90.3? You cannot. You do not have the data for that. For me to, give you the nth percentile of age, I will need to have all the data for all the 90.3 centimeter boys. I'll need to put all of them together over here. Then I'll need to check what their ages are. And based on that data, I can give you the nth percentile of age given the height. Do you understand this? Yeah. I am given the nth percentile of height given whatever age. I cannot find the nth percentile of age given the height. I need different kind of data for that. right? I'll need to, put them in different type of groups. This group will not, look, where is 90.3 over here? Look at 2 years, 3 months. Do I know where is 90.3 over here? I know it is somewhere over here, but look at that. This is 50th percentile. This is 85th percentile. I don't even know, where does this lie? 90.3 lie over here. Over here, I know it is somewhere over here. I don't know whether it is at 20th percentile. It could be at 40th percentile. I really don't know, right? So then this is one very important point that we need to understand, on which many people make mistake. When I'm given the nth percentile of height given age, I cannot find the nth percentile of age given height. It does not work that way. Are we clear about that? Once you understand this, then most of the questions will be very simple. Is there a problem till now? Are we good with this? Okay, since I haven't got any queries on this, so I'm going to continue. I'm going to assume that you've understood this point. Yeah. All right. Let's go on to the second tab. Now, this was the second tab. What this says is the graph shows the percentile distribution of weight. So the graph shows the percentile distribution. Again, it's a percentile distribution, just like we had in the table, but now it is in the form of a graph. Distribution of weight in kilograms for heights from 80 centimeters to 120. Look, now, just like ages were defined, for these ages, we were given percentiles of height. Now we are given percentiles of weight, but not with age. Now we are given percentiles of weight with height. So I have an 80 centimeter, 85. Again, I did the same thing. I brought together all the 80 centimeter boys, and then I checked the weight of all of these boys. Then I said, all right, so, now I have, look at these graphs. I have the third percentile given to me by this lowest line, the black line. Then I have the 15th percentile by the red line, then 50th percentile by the yellow line. Then blue line gives 85th percentile and the purple line gives 97th percentile, right? So it is exactly, the data is very similar to this, just that over here it is in the form of a table and over here it is in the form of a graph, right? I'm given the nth percentile of weight given your height. Yeah, based on the height, I'm calculating the percentile of weight. Okay, in a model population, again, we're talking about a model population because in the first tab, they told us what a model population is. Yeah, a large population of boys ages 2 to 5. Okay, for n is equal to this, the nth percentile in weight for a given height is the unique weight among boys of that height that is greater than or equal to n%, exactly the way it was defined for us over here as well, right? And we do understand how it was defined, right? If you are a little confused, just go back to thinking about 99 percentile of score. I want a 99 percentile score in GMAT, which means I want a really good score, which means that I've done much better than most other people, right? So then, so a higher percentile means a higher weight over here, and a higher percentile of height means a higher height over here, right? Okay, and less than or equal to 100 minus n% of weights of boys of that particular height. So essentially, they have defined your nth percentile in exactly the same way. Are we good with this? Yeah. Now, what this means is just that how are we going to read the data over here? If someone's height is 110 centimeters, if a boy's height is 110 centimeters, look at this. This gives me the weight at 3 percentile, right? What is this? This is almost equal to 16. All right. Then, of course, it's increasing, increasing, increasing. I come over here at 97th percentile. I'm getting a 22. So the weight over here is 22 kgs. Here, the weight is 16 kgs. So the data is exactly like this, just that, in fact, a little harder to read here because now it is in the form of a graph. So we have to look at what it corresponds to. But essentially, the data is exactly the same in this as well. Keep in mind, this is giving us weight percentiles for height, not for age. This is giving us height percentiles for age. Yeah. Any issues in understanding these two graphs? These are two separate graphs. They are not interrelated. We don't have to worry about that. But do you understand both the graphs? They're very, very similar in the kind of data they give, just for different variables, right? Okay, let's take a look at it then. Consider an individual boy from a model population. Model population, the or that big group of boys in the age 2 to 5. Suppose that from age 2 through 5, this boy's weight is at the 97th percentile for his height. So 97th percentile of weight essentially means that the boy lies on this purple line, right? For all the heights, for whatever his height is, for his height, the weight was always 97th percentile, yeah? And his height is at the 97th percentile for his age. So this one, essentially from 2 to 5, his height was at the 97th percentile. So essentially what I'm thinking is that, okay, this boy, when he was 2 years old, his height was 92.9 centimeters because he was at 97th percentile. And a height of 92.9 meters is centimeters is somewhere over here. So his weight is over here, 16. So his weight was 16 kgs at 2 years. Then when he was at 2 years 3 months, then his height was 95.7, and the 97th percentile of 95.7 height, 95, let's approximate to 95, is over here. So this would be about 17. So then he was 17 kgs, right? So his weight is always lying on the purple line, and his height we'll get from this last column, right? Okay. Now, which one of the following statements must be true of the boy at age 5 years, 0 months? So I need to now talk about what must be true for this particular. At 5 years, 0 months, one thing I know for sure is that his height is equal to 118.7 and his weight is equal to, because height of 118.7 is going to lie, let's say, somewhere over here. So his weight is going to be somewhere over here, which I would say perhaps about 26.5 or something. So let's say 26.5, right, at 5 years. Now, which of the following must be true? Must be true. His age is at the 97th percentile for his height. What did we talk about? We said that since I have been given data of height percentile, nth percentile of height, given the age for his age, that does not mean that I can reverse the relation, right? I need very different data for that. So then this given data cannot give me anything about this. His age is at the 90, this I cannot find, yeah? Besides, if you just think about it logically, I'm saying that this boy is tall for his age, right? Because I'm saying that he's at the 95th percentile of height, right? So he's tall for his age. Does it also mean that he's old for his height? Age is at 97th percentile will essentially mean that, right, that he's quite old in all the people who have his height. That's not true. If anything, I know that he's young for his height, right? So the relation would actually be the opposite. But what exactly is the relation, that I don't know, because as I said, I need very different data. So essentially, of course, I know that I cannot find this. And even if I try to find it, I'm quite certain that his age percentile will be very small, right? Even if I'm going to try to find it, most likely this age percentile will be very small. Anyway, this is irrelevant. I'll just cross it off. I don't even need to think all that. I'll just cross it off. I know I have no information about the percentile of age based on, for height. His weight is at the 97th percentile for his age. Once again, I have no information. I have weight with relative to height, 9th percentile of weight, not with relative to age. These relations don't really work this way, as I said, because the data that you take is very different for each one of these relationships. So you cannot just use the transitive property, let's say, right? That doesn't work. Okay, so this is also not correct. His height is at the 97th percentile for his weight. Yet again, I know the nth percentile of weight for height, but height is at 97th percentile for weight. I cannot establish this as we discussed before. So then this is also incorrect, and these three we should just eliminate right away. Yeah. All right. Now, his weight is approximately 166% of his weight at age 2 years, 0 months. So let me find his, I know I found his weight at 5 years. I want to find whether his weight is approximately this percent of his weight at age 2 years. Age 2 years, 0 months, his height is, now let me just write down for this. I say his height is 92.9. Guys, when you are doing the question, this MSR question, ensure that you go to tab 1, you say, all right, at 2 years, I have to find the height. Write that down. You say at 2, I say H is equal to 92.9. Go to the next tab. Now my H is 92.9. Where is 92.9? It is about here, 93, right? Weight is what? 16. So weight is equal to 16 because the weight is also on the 97th percentile. Now I have my two weights, right? I mean, I have to write very little, but I should write this because these are two different graphs. In case I'm calculating, I'm finding out a particular value from one graph, I need to write it down to ensure that I do not make a mistake when I'm checking in the other graph. And this is all you need to do, right? You don't need the two graphs side by side. Yeah. Okay, so now his weight is approximately 166% of his weight at 2 years, or his weight is approximately 197% is nothing but 200%, right? 200% is like twice, right? So then his weight is certainly not 200% because twice of 16 is 32. So this must be 166%, nothing else is possible. So my answer over here would be D, right? Any issues over here in any one of the options? Okay, let's discuss it now. So B is a boy, aged 4 years, 3 months. Again, the data is exactly the same as the previous question. So 4 years, 3 months, and his height is 110 centimeters, so lying over here. And we said weight is 19 kgs, 110 is here. And we said just above, right? We said, yeah, it's just above the 50th percentile, right? So for each of the following, select yes if it must be true of B relative to a model population. Fine. At least 15% of boys at the same height have a weight. So we're talking about this boy relative to the model. So at least 15% of the boys at the same height, we're talking about 110 centimeters, right? Have a weight. So essentially we're looking at this graph at this tab. So at the same height, so this is the height that we're talking about, have a weight that is less than or equal to that of B. Certainly not just 15%, in fact 50%, right? Have a weight that is less than or equal to that of B. So definitely the answer over here is yes. Is that okay, right? Let's move on to the next one. Now, at least 80% of boys at this age, which age are we talking about? This one, right? At least 80% of boys at this age have heights within 10% of B's height. Okay, so what is B's height? B's height is 110 centimeters. So within 10%, 10% of this is 11. So when I add to it, I'm going to get a 121. And when I subtract from it, I'll get a 99, right? So within 10% means that within 99 to 121, we're saying at least 80% of the boys of this age have heights within 10% of B's height, between 99 to 121. All right, look at this. And I need 80%. Here, my 15th percentile is at 100.5, which is within 99 to 121. And my 97th percentile is also within the 121, right? So certainly, obviously, starting from 15% up to 97% for sure lies in this. I mean, and we can pretty much say that, of course, all these 3% will also lie within 121, but let's not jump to those conclusions because the data is not there in the graph. But for sure, we can say that from this 15% till this 97%, certainly all these people do lie within this range, right? And then it is, of course, 82%, right? So at least 80%, certainly we have, I can see 82% people lying in this range for sure, right? So my answer would be yes over here as well. Do you understand this? Is this okay? Any doubts here? I'll wait for a second, tell me. Okay. Yes, it's almost impossible. Yes, that's true. All right. So is this understood now? Quite a few of you got this statement incorrect, right? Now, do you understand? All right. Let's look at the last one. B's height is less than that of, so height is 110 centimeters, less than that of at most 3% of boys at age 4 years, 0 months. So age 4 years, 0 months is here. The bee's height is 110 centimeters, which means that it is going to lie somewhere over here, right? Between these two. So somewhere, let's say about 90th percentile. So can I say bee's height, that is 110, is less than at most 3% of boys. It's less than at most 3% of boys. That is, it is lying somewhere in between over here, right? 110 centimeters. My 3% is already at 111.2, whereas this height has to be at 110 in between over here, right? So B's height is less than at most 3%. It is not must be true. There could be certainly, let's say if it is at 90th percentile, then B's height could be less than 10% of the boys. Do we understand? It is in between these two, right? I don't know at which percentile 110 is. Is it must be true? Is it necessary that B's height is less than at maximum 3% of the boys at this age? No. Right? It could be less than even 10% of the boys. It could be less than 12% of the boys, 13% of the boys. I don't know, 110 could lie at any percentile over here between 85th to 97. Yeah, so over here the answer is no. This is not necessarily true.